By nature, VRFs are absolute. They're there to keep routes separate, but perhaps we have a service that our customers need to access. For this to work, we will want to share our routes with a customer. We can do this with route leaking. If you've watched the first 3 videos, you'll be quite familiar with this topology. This time, we're just going to add a new network to each core router. These networks offer shared services to our customers. To start with, our customers will not be able to reach these networks. Our job will be to make sure that they can, while still keeping customers separate from each other. For our shared services, we'll create a new VRF. We'll leave the global routing table for infrastructure and forwarding only. We'll also export and import all routes with route target 65001. This needs to be done on both of our core routers. Now we'll create our networks and put them straight into the correct VRF. For us, the easiest way to advertise these routes is in BGP. There'd be no real advantage to configuring a new routing protocol for these networks. If we did, we'd eventually have to redistribute them into BGP anyway. We can quickly check that the routes are converged on both cores. What's next? For our shared services to work, we need to reach the customer networks. For that, we need to export routes from the customer VRFs. We're going to use a different route target here. 123 will be used for any customer route that needs to be imported into the shared VRF. Notice that this means we can use more than one route target on a set of routes. This gives us a bit more control over what's going on. We will also need to get the shared routes into the customer's VRFs. We repeat this config on the second core. Having a look at each routing table, we can see that the shared services VRF has the customer routes. I would like to draw your attention to the 10.10.0.0 network in the shared VRF. This is the overlapping IP space that each of our customers have. Now that it's back in the same VRF, overlapping is once again a problem. BGP will essentially just pick one and ignore the other. Customers also have access to shared routes, but they still don't have access to each other. This is all very well and good, but this leaks all routes within a VRF. What if a customer wants to be a bit more selective in what they're leaking? Well, yes, we can do that too. Remember how a route target is attached to a BGP prefix as a community? Well, we can fiddle with the communities to control what's imported and what's exported. Let's say, for example, that customer A does not want the 10.20.0.0 prefix exported to the shared VRF. First, take a look at the prefix in the BGP database. See the extended communities? These are route targets. 65,010 is fine. We use that to share routes across the core. 65,123 is the problem. As long as it's there, it will be imported into the shared VRF. There are a few steps in removing this route target. First, we need a prefix list to identify this route. Then we create a route map. This matches the prefix list we just created and then sets the route targets that we should see. This will override the existing list, so we include 65,010, but we don't include 65,123. Now that we've got our logic in place, we can apply it directly to the customer VRF in the IPv4 address family. When we're filtering route targets, we call it an export map. If we now take a look at the prefix in BGP, we see that nothing's changed yet. Give it a moment. BGP is a bit slow sometimes. Here we go. we now only have one route target attached to the prefix. We can further confirm this by looking at the shared VRF and seeing that this route is now gone. There is something interesting to point out before moving on. Notice that the route map didn't need a permit statement at the end. You normally need this with route maps. Export maps are a little bit different, and you don't need the permit here. There is a downside to this though. What if a customer created a route that we don't approve of? Let's see how this might look. On one of the customer B routers, we're creating a rogue route, 127.36.00. I call this a rogue route as this is part of the internet routing space. Unless the customer owns this network, which in our lab they don't, they shouldn't really be using it. And they've advertised this into EIGRP as well, which means that it will be automatically redistributed into BGP. We can confirm this by looking in the shared VRF. Now we shouldn't just block it like we did with the 10.20 network a moment ago. I say this because, well, we don't know what rogue route they're going to create next. Instead, we can create a whitelist of networks that they are allowed to export to us. Just to keep it brief, we'll only configure this for customer B. We'll start by removing the config that leaks all routes. Now we'll create a prefix list on each core router. These are the whitelists of networks that we'll leak for customer B. Just like before, we create a route map to match the prefix lists and set the route targets. Sorry, I just realized I've made a crucial mistake. We need to use the additive keyword here. Rather than overriding the list of route targets, we're adding the route target to any prefix in our list. And finally, we apply it as an export map in the VRF. Now when we check the prefix, it no longer has the shared services route target. Notice that this method doesn't stop BGP learning the route, but it does stop it propagating it through the core. If we have a look at a good route for comparison, we might need to wait for BGP to catch up. Okay, if we have a look at a good route for comparison, it still has the shared services route target attached. And we get final confirmation when we look at the shared VRF. The rogue route is gone, but all the good routes are still there. So, you've probably noticed that there are two ways to implement VRFs. You can use them on their own, or you can use them with a technology like MPLS. Technically, using VRFs without MPLS is called VRF Lite. Or you can use them with other technologies like VXLAN. If you want to see VRFs with VXLAN, I recommend you check out my VXLAN series. I hope you've enjoyed this series, and I'd like to see you again in whatever video comes next.